because those are two separate buttons now. Okay, and I am seeing your screen, so go for it.
Cool, thanks, Mia. So today we are going to be reviewing Daniel Windsor's PR, Loading Time Zone and Time Zone Link Names. This is part of the large Chrono feature that we're trying to get in. So we've got it labeled, we've got it tracked in both our code reviews project and the project that Mia's been maintaining, which has very fine-grained status for all the remaining tasks. We've merged the bulk of CS+20 Chrono, but these time zones and leap seconds and parsing and formatting remain to be done. So there was a lot of confusion and uncertainty when we first started looking at this because this was standardized in a way that's pretty convenient to implement on POSIX systems. You just get the IANA database, which is apparently just part of the system. And it's not nearly as convenient on Windows, but fortunately we have discovered that the ICU library for Unicode has actually been added to Windows itself as part of the 19H1, I believe, version. So we're going to take a dependency on this, which will mean that we're doing something a little bit unusual. It's going to be a feature that only works on sufficiently modern OS. We have done this in the past. Always for technical reasons. We don't try to, withhold features to make people upgrade or anything like that because we don't care. We did this with shared mutex, whose only purpose in life is for performance. So we required SRW lock on, I believe it was at the time, I want to say Windows 7 and above. And if you're running this on an earlier OS that we supported at the time, it just wouldn't run. And we had no customer complaints about that because we had communicated that up front. In this case, we do not want to be in the business of distributing an enormous library as part of the STL that we then can't really update without requiring people to recompile, relink, and reship their apps, which they need to be able to do for security, but for just everyday or common time zone updates, that would be very inconvenient. So it's very fortunate that this is part of Windows, but it means that it will only work on sufficiently modern OSs. Hopefully that won't be a huge deal, especially by the time this ships and users upgrade and then they ship their apps to end users. But it is something that we'll need to call out in the documentation. So Daniel and Mia have been looking into ICU and how to convert the information returned by these APIs to something that will be able to implement the standard. And I am also getting up to speed on this myself. So I'll be learning about this as I review. I've reviewed this 3 days ago. But the PR has changed since then, and I always see more on a second glance. So I think we can now start looking at the files, but do feel free to jump in, Daniel and me, if I'm skipping over anything or if I get something wrong, because I am not an expert here. Okay, so let's look at the files. A couple of these files are actually ones that I had added. So one of the things we discovered was that the initial PR just failed in the test harness. And I was like, hey, why is it failing? Does it pass locally? And it was passing locally. And the reason was that our GitHub CI system uses Windows Server 2019 Data Center. Turns out that this is older than the 19H1 release that we are going to require for ICU. So a couple of these files are going to switch our virtual machine scale set over to a client version of Windows 10, which is apparently totally usable in Azure. It's going to be the latest 20H2 release enterprise. So I created a test PR with this. Daniel picked it up, and now that test PR is gone. So this will be folded into this PR. Then when this merges into main, we'll start using the Win10 SKU there. And at some point, we'll probably go back to the server SKU when it's officially updated. But for now, it looks like this is reasonable. We haven't seen any perf issues either. So I wrote this refactoring, so it looks good to me. We're basically lifting out previously hard-coded things, but Windows Server SKU is no longer descriptive. We're also selecting Gen 2 because I read about this Generation 2 VMs that might be faster. They use like UEFI boot. I think that's what G2 means, and I think that's what Hyper-V Generation V2 means, and this seems to pass, so we're going to go with it. So that's these changes. Similarly, Azure Pipelines YAML, this is switching us over to the new pool that I created. I suffixed it with Win10 as a reminder. So that's all good. Okay, so we've got changes to Chrono. I previously looked at these files. They look like they haven't changed much. I'm just going to double check. Saw these. I did notice that this file has accumulated out of order names, but that was from a previous PR. I'm not going to comment on this. When we do the final merge, it'll show up and we can sort it at that time. I don't want to disrupt this PR. So we're adding these exports still. We're adding the new test in sorted order. We've got the new matrix, usual latest matrix. Okay, so let's look at everything else. Let's start with picking this TZDBH. Okay, let's see. Casey has a proposed change to double underscore MSVC TZDB.h PP. Do we have HPP suffixes yet? I thought they were all H's. Oh no, we do have for the internal one. Oh, that's right. We do have one already. We've got MSVC system error ABI HP. I forgot that we started doing this and then we just sort of either we haven't added anything since then, or I relentlessly continued following the old approach with xmeow.h. Yeah,
I think the root headers happened before.
Okay.
We decided
okay, so
on this direction. It's really close. But
okay,
yeah,
so I wasn't a bad kitty. That's good. Yeah, that's right. I did start that pretty early. Yeah, it's certainly consistent with this. I have no objection as long as we update the guard macros accordingly. So I'll add that comment as a reminder. Note that we should update the idempotency guard macros accordingly. And also the let me actually get that wiki link. I think of it as hack these files, but it's called files to edit now when adding or removing files. Also the files in, I'll just call it the files to edit, which is not nearly as catchy as hack these files. Fortunately, since we haven't merged it to the internal repo yet, there are no other files internally that need to be changed. Okay, update the idempotency guard macros accordingly, and the files to edit will need to be updated for this rename. Okay, agreed. That can either be part of this PR or actually, I'll add this. Maybe 3 points. I'm fine with such a renaming, but it can also be tracked as a card in the Chrono project. 3 bullet points. There we go. If you don't want to add extra complexity to this PR, because we can do that at the end if necessary. Okay, this is all grammatical. Yes. Okay, so what's changing here? So we got an enum class double underscore stood TZDB error. We've got this double underscore stood TZDB prefix as stuff for this sort of binary stable flat C API. So that's good. Everything here is now underscore capital ugly. We got success, win error, ICU error. Okay. Underlying type is int by default. That seems fine. We got a struct stood TZDB time zones info that has an underscore error, one of these. Time zone data version currently being used, consecare star under version, size T, num time zones. Hopefully we never have more than 2 to the 32. This may actually come from the When API. I'm assuming that's why it's IST. Ordered list of null terminated time zone link names, consecare double star names, contains corresponding tree for every name if there's no such thing as link, it's links. Is named, or the data member is named links, not link. So links of I is, if links of I is null putter, then names of I is a time zone. If links of I is non-null putter, then names of I is a time zone link to time zone with name links of I. Okay. We got a struct std_tz_db current zone info that stores the std_tz_db error and a consecare star tz name. Okay, that all looks good. Externcy APIs. We are adding two. Are we adding exports? So we should be adding get, and delete. Here's the gets. Or deletes.
The
Are they in
deletes
Chrono?
are
There's
just
just no
underneath.
space because
Yeah.
they were related.
Sorry, I didn't catch that.
There's no return because they were related.
There's no return.
Look at the function definitions. There's just no return between them.
Yeah, no new line.
Your
If
line.
you go back to where you were.
Did I get confused by what I was looking at?
Yeah, they're just
Where is
directly
that?
adjacent.
Oh, I see. They're stacked. Thanks. I view this as like wrapping. I was like, oh, that's one and that's another, but there's actually four here. Okay, thanks. I completely failed to parse that. Great. So there's four. Nothing is being forgotten. Okay, so these are no discard. They return the corresponding pointer to struct. They're stood call. They take nothing. They're no accept and extern seed. That's good. Underscore capital info. Yep, that all looks good. Okay, they're being declared there, and they're extern C. Okay, this is looking good. Aside from that comment. Yep. Okay, let's see. Why don't we look at the source file that implements those? Okay, so we're including some headers. We need atomic, icu.h, memory, string view, x file system. I think that's for that x get last error. Okay, so we got an unnamed namespace. We got an enum class, ICU API level backed by unsigned long. Not set detecting has failed, has ICU addresses. Okay. I guess this is the success one where we've got everything. We got a struct ICU functions table with a bunch of std atomics. Have to qualify because we're in an unnamed namespace. These are, here we're consistently using ugly names, which is fine. In fact, we often do this in source files. It makes it easier to move code in and out of headers if necessary. Even though in an unnamed namespace in a source file, we could use non-ugly names if we wanted. So all these atomics are being initialized with null putter. This enum is being initialized with not set. They're all underscore pointer to function. Yep. And these are just copying the names, which is good, nice and consistent. Yep, that looks good. Then we have a table. Okay, so now we've got some global data. Let's think about where this lives. This is being added to the atomic weight DLL. So there's going to be a single copy of this per STL DLL loaded, which is normally one per process. But it's essentially the universe as far as we care. There will not be multiple copies of this linked into every user binary. When static linking, there will be just that one copy, but that's fine. So this looks good. Not worried about mismatch or things like that. Okay, so now there's a helper function. So like here we have just T, but that's, again, this is okay. It's a little bit inconsistent to have the non-ugly or the non-ugly identifier in a file that is otherwise pretty insistent. Do I comment on that? No, the entire file then just starts using non-ugly.
The entire file
parameters.
uses ugly except for the function overloads because those are just what they are in the sort of header file for ICU.
I see. It's trying to match those. Okay.
Yeah.
I don't really care about the T here. I mean, it could be tie, but it's within the level of inconsistency that we have in source already. So that's fine. Okay, so we got template on type name. Actually, type name itself is inconsistent. I'll comment on this. We try to use class in product code. It's not a huge deal. But if we're going to be consistent, class in product code, even though I personally prefer type name. The T can remain T, I suppose. The T can remain T, but if this file is trying to use ugly names everywhere except function parameters that match ICU, then tie would be somewhat more consistent. Okay, very cosmetic. Can't help myself. Void load address, we can take a const h module underscore module, just an atomic of tref stored pointer to function. LPC stir narrow function name. Do we usually use that, or do we usually use get proc address w? Nope, I don't want Outlook. I want this. Could have sworn we used w. Get proc address w. No, interesting. So when API sup, that, oh no, that's not. Oh yeah, this is it. Okay, we do use narrow. There may not even be a wide version.
There
Okay.
isn't.
Okay, cool. I'm so used to Windows being everything wide. Okay, LPC stir, long pointer, true const, narrow string. Okay, fun name. Technically, this could be top level const, but with that type def, yeah, whatever. It's a pretty short function. dword ref underscore last error. Let's see, does this need to be no except? It could be. Would that provide value? Not really, because this is all header only, or sorry, it's all going to be compiled into a single file. The compiler can see that this stuff won't throw. So there's not really an advantage to marking header only. I mean, we could, but we're not super disciplined about that in internal helpers. So I think it's fine. Okay, so we get proc address from the H module, look for the function, reinterpret to the T, which is the pointer to function type. And we store that in PFN. If we got it, then store with relaxed ordering. We just need atomicity. Otherwise, don't store, but write out through an out parameter, get last error. Is this being called in a way that has an out param? Because we do have a return value that is totally available. Yeah, this avoids changing it, or this avoids like assigning success to it. So I see why this is happening. So that's good. Out params are a little unusual, but that pattern seems fine. Okay, so now we've got, yeah, it's void. We've got a helper here, no discard, ICU API level, init ICU functions. We take a level, we do modify it. Okay, it's no except. Okay, so we're going to call in a loop, compare exchange weak because it's a loop. And while we can't, let's see, we expect detecting, and we would like to exchange in level. As long as we can't, we're going to loop. If the level is greater than detecting, that's interesting. I forgot that we can compare enum classes for greater than. I guess we can. If we're greater than detecting, so either failed or has ICU addresses, then we should return it. But if it's not, then okay. So that's interesting. We were storing the addresses of memory order relaxed. We haven't done anything with level yet. And here, this is running with sequential consistency, which is the default and strong. So that's good. It may be possible to use like acquire release, but I never like thinking about that unless performance is absolutely critical. Okay, so if we have found, detecting, and exchanged in level, then we're going to set it to has failed. This is the local variable before we actually try to do work. Yeah, and then only if we succeed completely do we set his IC addresses. Okay, so we tried to load the module, IC module. Here's a wide string, IC DLL, search system 32. If we loaded the module, if we don't, then store in the API level with release. That's kind of weird to mix memory order release with full sequential consistency.
So I can't really comment on this. This is sort of piggybacked off the atomic stuff from atomic.cpp. I wasn't too familiar with how this works. So
yeah, if it's like exactly imitating the existing precedent, then I guess it's fine. I'm always scared of this because it is significantly above my familiarity with atomics. Like I understand full SC, I understand acquire release. Things that mix the two, I do not actually understand. In particular, I don't know if memory order release handshakes with sequential consistency. I think it does because SC is like strictly stronger than acquire release, but I could be wrong. It's weird though to mix full SC with not. Honestly, I would be happier if this were just full SC. Like if you just drop this, then it's just store level, load, and then if somebody complains, hey, we've got memory barriers in ARM, we can go revisit it in the future. This is actually all internal to one function. Yeah, this function essentially communicate. Well, no, it's within the STL's DLL, so it doesn't even need to communicate with anything. So we can actually change how this works in the future. How many? Oh, this one's also this one's acquiring. Okay, so you do have acquire release. Man, so that tells me that if this is being acquired and released, maybe that should be acrel above, and then I would feel okay because it would be consistent. These are all the pointers to functions. So it's the API level. Actually, I guess I should be searching for what this? Yeah, because this is the struct. How many references are there? Oh, good, only 3. Much easier to reason about. You acquire when you load, you store when you release. So this compare exchange, I think this really should be acquire release. And then it's the clear handshake. And it's in fact slightly faster in theory than sequential consistency. I believe this should be, we're using stood here, stood memory order acrel as the lines below use acquire and release ordering instead of full sequential consistency. The background here on atomics is that sequential consistency is the one that humans can reason about. That's the one where if all of the accesses to an atomic use sequential consistency, then the program behaves as if every thread executes its instructions as far as the atomics are concerned. Like the non-atomic operations can still be arbitrarily reordered amongst themselves. But as far as the atomics are concerned, the threads execute as if they're interleaved in some total ordering. But you can't like reorder instructions as observed from one thread happening in another thread. So if you think real hard, usually you can reason about, okay, what happens if thread A executes this load and then thread B executes this store and thread A now loads that, things like that. Then there's a couple extra things you get to assume, like things that happen to one atomic happen on a consistent timeline. The moment you go to weaker than sequential consistency ordering, now it's possible for one thread to observe things happening in a different order on another thread. There's no single global total ordering of operations. Acquire and release prevent certain kinds of reorderings from being observed, which allow you to do something like, write to ordinary data members and then use a store release to mark it as done, and then another thread will load acquire from that atomic and then observe those ordinary data members, and you have a guarantee that the accesses to the ordinary data members aren't going to be reordered in a way that flows past that store, release, load, acquire, and would allow you to read or write, garbage data. So that's what's happening here. This API level is being used to synchronize, to guard the function pointers. So that's interesting. What's also interesting is that the rest of these are atomic. This is this actually preventing anybody from simultaneously modifying this thing? Let me read on, but then I'm gonna go back and think, do we actually need atomics for all of the function pointers, or could they just be plain? Because it looks like this is providing all the guarding, but maybe I'm wrong. We'll see. Okay, so we load the ICO DLL. This is another topic of complexity, but I believe search system 32 just looks for the one in the system and is not going to be deceived by anything local. But let's check MSDN system 32. How did they know that the Windows API is my magical weak point? Okay. If this value is used, Windows System 32 search for the DL and its dependencies. Directories in the standard search path are not searched. Okay. So we only want the system, which is good. We're never going to pick up some local ICU DLL in the directory or anything. We don't care about this stuff because we need 19H1. Okay, great. That's exactly what we want. And what's that null pointer argument? H file. Yep, must be null. Great. Okay, let's see. So if we loaded the module, if we don't load the module, we're going to store failed to the level. Okay, that's good. Then we're going to return it. But if we do load it, collect at least one error if any get proc address call fails. dword last error initialized to success. If any of these write an error from that load address function, then that'll overwrite this and it'll never go back to success. We need to make sure there's no copy pastos, canonical, default, open time zone, choose data version, close, count, unext. Okay. If everything succeeded, set the local variable to has IC addresses. Otherwise, okay, so what's going on here? We failed. We loaded get last error here. Why are we doing this? So we've got in IC functions, this is one of these had failed. But maybe one succeeded. Okay, and then something calling this is going to look at get proc address because it's sort of communicating state outside of the usual return value. It's actually in IC API functions. I think it's the header, or let me see who calls this. It's acquire that calls this, or something calls acquire. Ooh, but what if this didn't even call get proc address? Okay. Whenever I see any state being communicated outside of the usual return values, I get very wary because the return values are comprehensible, global variables are not. Let's see. Yeah, this is calling report error info. It just says win error. Do we ever call get last or get last error? Maybe report error does that. Let's see what that does. Nope, it just sets error.
So the report errors are just something there to make it look a bit nicer.
Yeah.
But the idea is the API surface here returns win error, and then the caller of this guy will call get last error to get the actual Windows error. So, and there's no real way around that, because I can't call get last, and I can't call get last error from outside of the implementation files.
Yeah, but why can't we just return it as a return value?
Well, it doesn't matter, because when you call, when you throw the exception, I don't think you pass in an error code. I think it just uses whatever value is in get last error.
Oh, because you're trying to use the existing X get last error. We don't have a function that will.
There might be, but I was just following the same post conditions as the existing function in this file.
Yeah, it's a little weird, because the get last error is reasonable if, like, you call a Windows API, it fails, and then we immediately, set an error code or we throw an exception. But here there's a lot more going on, and which makes me nervous. So,
and the only reason I did this is so that I didn't have to assign these older variables and then check all the variables are null, and then it was just to make the code look smaller, because it was getting huge and it's only going to get bigger.
Well, I'm collecting it here is fine. I understand how this works. You set success. These only write to this variable if they see a get last error. So the region where the get last error global variable has to store stuff is very small. It's literally between here and it's literally between here and here. And then everything is just, local variables, and I know how those work. But this is trying to go back and use the get last error global to communicate stuff. So this is then, you're saying it's read by X get last error, I guess in Chrono, or maybe elsewhere. Yeah, here. Yeah, when we designed this for file system, we didn't think about anybody else needing it. Yeah, it makes an error code. There's in theory nothing, well, except that it wouldn't be. No, you can have an externcy function that throws. We would just mark it as no except false. That might be better. Who else throws system error? Nope, that's not what I want. No, that's not what I want either. Okay, we do have some things throwing system error. File system is willing to do it header only because it can drag in all a system error. Does Chrono drag in system error? I don't think it does. I'm not on feature Chrono right now. It does not right now. Yeah, you got Xthread stuff. Currently, I'm thinking, would it make more sense and be less risky to add a function to the API surface that essentially does this, but instead of calling get last error, accepts an int, and then wraps it in an error code and throws a system error. That would allow us to not communicate information through set get last error. Who else calls this? If the number of callers is relatively small, then it wouldn't be a larger factoring. Only 2, so that's not too bad. This is from this is after calling std_tzDB get current zone or std_tzDB get time zones. That's it, actually, at least if I've got all the files open. Yeah, except for the tests. So get current zone. Oh, but this is gonna. This causes a bunch of stuff. Well, this then turn report error. So where does the get last error come from? Is it only ever from this loading APIs, or could it also be from
It can
this
be
ICU
from
stuff?
some stuff to string translation as well.
Oh, okay. Okay, if that mechanism is consistent, then I suppose get last error is fine. I'm still nervous about it, but mostly like, what if something resets it?
I originally bottled up the error because I didn't like it either, but then I
Mhm.
realized I didn't have a way to actually call with the error code, so then I changed.
Yeah, we could, like, there's nothing stopping us from adding a function that does this basically, because the atomic weight DLL could include system error and then have a function that does this, except it's extern C, no except false, takes an int, does this stuff. We could do that because we can add new functions. But aside from just being nervous, I don't have a concrete reason to do that. Aside from, yeah, just not seeing, whenever that scope is more than like one function, I get nervous that we're going to stomp on the state because Windows is willing to reset this at basically any point. Let me just inspect this a little more. So reset last error code for thread in case a later get proc address resets it. I'm going to comment on the grammar here. It's not hyphenated. Okay, so we set if it's failed. So this would be the scenario like failure, but success, 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 which would be weird. Shouldn't actually happen. But setting it wouldn't be harmful in that case. Set the failure, store return. So who calls init ICU functions now that this can emit a get last error? Only two calls, so acquire if you're detecting. If acquire is less than success, then report error, win error. Okay. Those are the only two places. But then I thought report error didn't look at get last error. It just sets win error and then releases it. Oh, but something after that might get last error. Okay, so oh yeah, this is the get time zones, and we do return rapidly. So that's a point in this favor. Yeah, we let me see. We sell last error. We do that report error thing, which assigns to the error member. We detect that here, and then we get last error. So the actual runtime span that the get last error has to preserve that information is actually pretty small. It just looks like a lot because it's jumping through a bunch of functions. Okay, that makes me less nervous. I guess I'm okay with that. Okay, and then we store, release, and return. Okay, so then the question popping up the stack was, are we just relying on API level to guard everything? And if so, do these need to be atomic? My hypothesis is that they do not need to be atomic, but let's see. So first thing to check is who is accessing API level. So API level starts off as not set. We expect that it's going to be, oh wait, does somebody set detecting? No, nobody says detecting. Okay, so it starts off not set. Wait, what are we calling in ICU functions with? I need to see the usage. Oh, okay, this is interesting. Acquire ICU functions loads the current value. If it's less or equal to detecting, which is not set or detecting, yep. then we pass the level itself to in ICU functions. Get what it returns, then return it. Okay, that's interesting. So here, okay, this is what we just observed. We're trying to see, okay, if it hasn't, oh, I see, this is expected, this is what we're trying to assign. If it's still what we saw, then, this is the value we originally observed. We're trying to assign detecting to it. As long as we can't, if somebody else then completed it, because that's what we're going to. Oh, yeah, this is modified on output. If it's exceeded, then return that. Otherwise, try to look for. Yeah, again, it's going to be not set or detecting if it still hasn't changed. So only one caller should get through to here, because initially it's not set. Then anybody who simultaneously calls this will see, is it starting as not set and then going to detecting. If that changes, other ones will not observe it being not set. They'll see like detecting itself, and they'll continue spinning until something is done. So this is actually, I believe this is kind of like a mutex. It prevents multiple threads from doing this simultaneously. In fact, I sort of question whether this is this logic seems to be a bit more complicated than I would expect. The loading of this here basically. I guess if it's detecting, you want to spin, so that's why we go in here. I think that may need to be reworked. But assuming that only one thread can get in here, we would assign to all these ICU functions if they were ordinary variables, and then we would set either error or success, and then we store as we exit. Then that can be observed by everybody else. So acquire ICU functions then. If it's anything less than success, we error. And then otherwise we can just use stuff. Why is this not going through those atomics? Oh, because once we know that we can load them, then we can just call them. Is that right? Attempting to call this without the DLL being present? No, it's like, why do we have a direct call here? If these aren't wrappers or anything. Oh, they are wrappers. Okay. Okay, and then yeah, this goes through the get. Okay, so okay, that's fine. If everything is guarded with acquire, I think they don't need to be atomic. I think they can just be plain. We don't need atomicity because there's only going to be one modifier. Only one thread can go through here to assign these. And then once they're assigned, we can just load them normally. We don't need to, use a relaxed load or something, because we're never going to observe like a null putter being loaded or something in the middle of a write. So I think this can be dramatically simplified, or somewhat simplified. I think they can just be ordinary variables. And then the other question is, can we simplify the logic around API level? So it's got not set, detecting, has failed, has high ICU addresses. So we do need all these modes, because only one thread can be allowed to set it to this intermediate detecting state. It's weird that we spin. It would almost be better to have a mutex here. Although it should be so blindingly fast to, well, it's a bunch of get proc address calls. I don't know how fast those are. That's like a string lookup and stuff. It almost seems like it should be a mutex that would block. But then once it's actually Once it's actually set, then everything's fast. So it would only be, oh, if there's a bunch of contention, which we don't expect. It's probably fine for performance to do it this way. But is this logic more complicated than necessary? Let me think. I wish I could think about atomics faster. But I am very slow when it comes to reasoning about atomics. So we start at not set. We've got a whole bunch of, potentially a whole bunch of threads calling acquire ICU functions. So we try to load acquire, and then is this test correct? If we are less than or equal to detecting, so for not set, we definitely need to go do logic. If we're detecting, we also want to enter into a spin loop, basically. So I think this test is right. Yeah, if we're not set, we got to do work. If we're detecting, we at least need to block. But since we have no mutex here, we're going to spin, essentially. And then if we are either success or fail, then we're just going to return it. Okay, not set, detecting, success, fail, return it. And then once we've passed that in there, this is what to expect. This is what we'll return. So we should only get success or fail out of this. Okay, so this part is fine. Then going in here, if it's not set, we want to expect not set and put in detecting. Oh, this does not prohibit multiple threads from getting in there. Because if it is detecting, if one thread gets in there, sees not set, and moves up to detecting, and then another thread loads detecting and then tries to compare exchange detecting, this will also succeed and allow us to get in here. So actually, there is the potential for multiple threads to do this simultaneously. Oh, but that essentially prevents spinning. Yeah, that's okay. Maybe that's the reason I have atomics. And it's only if the first thread succeeds super fast and then sets, to success or failure, then this thread, the other thread that was trying to set detecting to detecting, will notice that and say, oh, okay, it actually succeeded. But if multiple threads get in here in the detecting phase, so this actually doesn't block. That's nice. If multiple threads get into detecting, then we need the atomicity, which is provided by the set, or the atomic store. Okay, so there's nothing wrong with this code. If we try to restructure it to be non-atomic pointers to functions, then this would need to block or spin. So either we'd have to accept spinning to say, oh, it's detecting, I need to wait. Let's see what that we could use atomic wait or something, which is that new CS+20 stuff, or we would need a mutex. And the cost here is not really big, I think, because it's a relaxed store, it's a relaxed load after that. This is fine. And interestingly, atomic ref could be used here because once everything is loaded, then we don't need to worry about contention on the reads. It's only the writes. But that would be like a super duper optimization. We don't need atomic ref. Okay, so I think I've finally convinced myself that this code is correct and reasonable, that we're not going to have data races or unnecessary spinning or like additional logic that we could just simplify. This is serving a purpose, and the atomics here are serving a purpose. So that seems good. Okay, yeah, in the future we can centralize this into WinAPI sup, or whatever succeeds that, which is the big table of function pointers. This would be V next because we can't do this right now, so this machinery is necessary now. But yeah, this big table of stuff that we need is how we try to load things that depend on the OS, like acquire SRW lock, try acquire, and this is a lot simpler. So that's all inherently transition. There's no need for transition comment because we know we're going to have to smash all this in vnext. Yeah, maybe it is worth a comment. I could see myself forgetting. So why don't we just store that right now? And VNX planning. Let's see, where do we have that? Flat C exports. And API loading code like for ICU. Yes. And there's one thing that we didn't want to consolidate, which is we can't allow vector to sneak back into the DLL. Can't allow, although in this case, I think we ended up not exporting something. It's going to live in the import lib. Or it's going to be an inline variable, but make sure to keep vector, string, etc. out of the DLL. Can't be too sure about that. Very scary. And API loading code like for ICU, make sure to keep vector, string, etc. out of the DL import lib. Okay. Note recorded. And I probably should have added a comment there. It's just going to say markdown. That's fine. Okay, so back here, we have acquired. We've gone through this. It's no discard. That's good. I think everything here has been no discard or void. Love no discards. That's good. That's good. Okay. And now here are the wrapper functions. These are all pretty simple now. Let's see. We've used Atomic. We've used ICU, Windows H. Yeah. Atomic, ICU, Windows H, XTSDB. This is also including memory and string view. I don't see cstd_int. We really should include that. Actually, yeah. Yeah. Although, does ICU provide int32t? Is that just part of its interface? Maybe that's reasonable. Assuming it's going to be this. It's kind of weird to see something not called, dword or whatever. Why did I do that? I should just say block.
If you just search the function, you can get straight to the header.
Okay.
There's docs on it. Second link.
Just put it in the chat.
Okay. Thanks. What is this garbage? This is programmatically generated documentation. This doesn't help me.
You can get to the header file just by saying go to source code for this file.
I don't. Oh, go to source code. Okay. Oh, I see. Okay, so it is part of ICU. So they're guaranteeing they're dragging it in 32. Okay, that's fine. Plus, it's compiling. It's not a big deal. Okay, so no discard. Can review these pretty fast. Since these are just very thin wrappers, we don't need to bother with top level const on these. So we're always going to load relaxed with nothing but atomicity and just call it. Yep. So here I want to make sure that there are no copy paste O's. And in theory that, arguments aren't being reordered, although that's less likely. So yep, that matches. Let me make sure that these are also all relaxed. Yeah, they're all relaxed. That's good. Okay, so we've got get canonical, ID, len, result capacity, system ID status, get default time zone, result capacity C, got open time zone ID enumeration, zone type, region, raw offset, EC, okay. Get TZ data version status, unenum close en, unenum count enec, unenum unext, en result length status. Okay, so now we've got a function here. What is this? So no discard, consecute star, allocate wide to narrow. We take input as a const char 16t star, input len, right, and tzb error ref. Okay, so we're going to convert wide and narrow, and we're going to use square brackets for the unique putter, and we're going to release. But who's going to get rid of this? This is in the unnamed namespace though, so I'm keeping like mix and matching of new square bracket and delete square bracket in the back of my head, but as long as this all remains within the DLL, we're fine. So this was releasing. Yeah. So it's going to be put into names and links, but then that cleanup function will delete square bracket the names and the links. So in all cases, the new square bracket and the delete square bracket live in the atomic weight DLL. There's no opportunity for users, users meaning us in the header, to use a replaced new or delete square bracket. So no potential for mismatch. That's good. A mismatch is very scary because it works all the time until a user replaces it and then it fails at runtime. We've had tons of issues with this in the past, so I try to always be on the lookout for it. Okay, so that's looking good, and because we're using unique putter, we don't need to worry too much about III issues or exception issues. So, okay, let's take a look at this. Okay, so this is interesting. This is going to load the FS code page, which is the specific thing that the file system does. I don't 100% know if this is appropriate because there's this weird like ACP thing. It might be reasonable. Where would we implement that? Here. Yeah, this is this can return UTF-8 in some cases. I think I got this from Steve in the UCRT. And then if our file API is ANSI, it'll return this weird OEMCP thing. Otherwise, it returns the ANSI code page as a value. I don't see anything inherently wrong with this. It might be wrong in a corner case. My vague understanding is that this is kind of specific to the file system. I'm not 100% sure if this is correct. Are we using this? Why are we mirroring this, I guess?
So the interface for time zones takes char stars and everything operates on the ICU with char 16.
I see. Okay. And then the interface, that's just specified. It's not specified to be UTF-8 or something. It's just the standard says the usual basic code page or whatever. Or
I couldn't find anything on encoding.
okay, it's probably the standards interpretation of an NTBS, null terminated byte string. The FS code page seems reasonable. It may be the result of a bug report down the road, but I think it's going to be correct for the majority of cases. I'm not an expert enough of an expert to say, oh yeah, there's definitely a bug there. I think we can live with this for now. Okay, we're going to take input, which is char 16, reinterpret that to const wchrt star. Okay. We're going to have, let's see, nitpick. I do notice that these could be top level const, and this is following const discipline, and it's a large function. Input, we immediately reinterpret. We don't do anything else with it. Input len, we just pass it. We don't modify that. Yeah, they could be top level const. Input and input len could be top level const. Pretty sure. Okay. And then we're going to use stdfs convert wide to narrow. Okay. What are these extra parameters here? Output stir and output len. Was that going to return the number of characters needed?
Yep.
Okay. I wrote this code. You'd think I would know, but I don't. Okay, so count result. If it wasn't success, then win error, null putter. Okay. And that'll contain we'll read the get less error. Then let's have a std unique putter of char bracket, data, new no throw, the char, the length plus 1 for null terminator. If we got null out of that, yeah, we can compare unique putter to null putter, then just return it. Otherwise, it's not null, it's got ownership. We can now scribble a null terminator. Why do we need to scribble a null terminator?
I believe one of the functions wouldn't let me give a size when using it.
You mean this or
No, later on. Because that
no?
doesn't-
I would expect that this stdfs convert wide to narrow should null terminate because it uses wide char to multibyte. Windows APIs generally, although it's always worth checking, are pretty consistent about null terminating. Like the one function in the CRT that doesn't is like just a horrible abomination, and it's called out in the documents.
Yeah, I can't say I ran into an error. I was just being precautious. So I could be extra null terminating, to be honest.
Oh, this explains that OEM CP. Yeah, still no idea what that thing is. Okay. Here's the null termination semantics. It does not null terminate an output string if the input string length is explicitly specified without a null terminating null character. To null terminate an output string for the function, the application should pass in -1 or explicitly count the terminating null character for the input string. Okay, so you either say -1, so it'll detect the null, or you say I got 10 characters and include the null character in that 10 or whatever. So what are we doing here? We are passing in the input length, which is being given to us by the user. That might not be -1, or it might not include the null terminator. So perhaps this preemptive null termination is, although this is assuming that, well, no, it's the very end of the count results. So that seems fine. Oh, I see you enum you next is returning the len. Okay, so that probably does not include the null terminator.
It does not.
Okay. Oh, yeah, that's our prefix. Yep. All right. Okay. Okay, so passing in a length, the length does not include a null terminator, so we're not going to get null termination from the conversion function. So the explicit writing of the null, we were told how many characters are going to be emitted. So this is the correct position to write the null. Okay, that's good. So const auto result. If it failed, set win error return. Otherwise, now we can finally release. Okay, good. Get canonical ID. This returns unique footer of char 16 array. Okay. Takes ID len, result len, error. Okay. Here I'm wondering, does this need to be zeroed out or something upon entry? I'm assuming it's going to be properly prepared when we call this. Okay, we got link buff len. This does not need to be static. For local constants, they can just be plain const expr. Static doesn't, it's not harmful, but doesn't really do anything. For arrays, it actually does make a difference, except in const expr functions themselves. You do want arrays to be static const expr so that they get burned into read-only memory, and the compiler will avoid generating code to push each element onto the stack to get a unique address. Unfortunately, if you have static const expr array, it, I believe, cannot be used within a const expr function because that staticness like removes it from the local const expr scope. So that's like a minor headache. I'll say this doesn't need to be static. Minimal const expr. Okay, link buff len 32. So we've got a stood unique putter with that type. We're going to new with no throw, that many char 16 T's. If we couldn't get it, then return null. Okay. Wondering if this should be no except, but again, this is just an internal helper. The compiler will be able to see that it should not need commit enforcement because like this is not going to throw. Okay. So this is ICU stuff. You got U error, is system. These are all being initialized. Call get canonical time zone ID. If it's ominous sounding buffer overflow error and result len is greater than 0. Let's see, we're told, oh, the buffer is too small, so we're going to reset. Yep, no opportunity for a leak here because we're giving it directly to reset. +1 for the null terminator. Okay. And then this is going to try again, but we don't want to. I'm wondering, like, should this be a loop or something? And in this case, you're going to give it one more try.
Because that
So
returns
this-
the correct length. So if this doesn't work, then
Yeah, it
it's
should
an actual
definitely
error.
not work. Yeah. So do that. Call it again. Same parameters. Here we've got a you failure macro. Set ICU error. We don't know what happened. Something ICU. Return null putter. Okay. Otherwise, if this thing did not specifically overflow, if it failed, or if the result len, which is in 32T, if it's less than or equal to 0, then again, it's some sort of ICU error. Okay, otherwise link buff. Okay. And that's local variable, so it's moved out, so it's great. Okay, so now we've got report error. Let's see. I'm pretty sure unique putter is not const expr. I don't think this needs to be const expr. Yeah, unique putter is not const expr yet, as far as I know, even though string and vector are. I think that these should just be dropped. Yeah, I'm not even going to double check. I'm pretty confident it's not const expr. As unique putter isn't const expr, I believe that const expr on these functions should be dropped. They're already it's a source file, so there's no question of adding inline or something. You just don't want any keywords there. Okay. So we got template, tie in. Naming nitpick is we usually say DX for the deleter of a unique putter. Detour makes me specifically think of destructor, which is not actually what that parameter is. It's a deleter, not a destructor. I'll also add a comment for that. Naming nitpick. We conventionally use DX for a unique putter's deleter. Detour suggests destructor, which is different. Okay. So template class tie class DX, no discard tie star, report error, std unique putter ref info, std tzdb error, assign, and then release. That's interesting. Why are we releasing ownership? It is no discard. Oh, this is that non-null putter. Yeah. If it's null putter, bad Alec. If it's not, then you got a thing. So that's why we release. Okay, so and as long as these are all no discard, there's no real opportunity for leaks. Okay. Okay, and then here, propagate error. Same signature, no error there. A bad Alec returns null putter and does not set std tzdb error. Let's see. Should this be parenthesized? I would recommend just dropping it. We're not making a temporary object here, and if we were, we would use parentheses. If the error is not success, then release. But if it is success, then bad Alec returns null putter. Okay. And then this will deallocate stuff if necessary.
Question, Stefan. This came up
Yes.
elsewhere when I was reviewing. In our, this is very minor. In our general preference for non-negated tests, does that also apply to ternary?
Yes, it does. In general, tests against null putter or like success failure, I don't immediately think, oh, we should avoid the negation here. It is true here that we could flip this and there would be no downside to it, I think. The cases where our downside is when it would, make the following logic more convoluted. In this case, it would just be flipping the sides of the ternary. This would, let's see how this would read. If info error is success, then return null putter. Otherwise, it's failure, so return release. I like that a little more. Plus the comment, because the comment talked about returning null putter, the fact that the first case is, hey, let's return null putter. That's actually a positive. It's a slight advantage. So I'll mention that. Thanks for bringing that up. We could avoid the negated condition here, which would make the commented null putter case occur first, which would be a slight benefit. Okay. Okay. Let's see. Nitpick. I think our anonymous namespaces usually end with anonymous namespace, not just namespace. Let me see if that's right. Anonymous namespace. Oh no, it's an unnamed namespace. Namespace. Yeah, that's the usual comment. There we go. Okay. Too many slashes. Yep, unnamed namespace. Okay, good. Let's see. Okay, so std tzdb get time zones. It's no discard, std call, no accept. Okay. On exit, if the info, which is the return value, if it's null putter, then bad Alec. If I can't help myself, I must nitpick. I like braces for temporaries. Or just drop them entirely, which is, I guess that's what I suggested here. Yeah, why don't I edit that? Not a function. Okay, if the info arrow, because it is a pointer to error, is when error, then we fail, call get less error. If it's ICU error, then runtime error interacting with ICU. Okay. Are we going to throw runtime error for this then? Yes, we're going to extra runtime error. Okay, good. Okay, we're still within the, wait, why are we down here? Oh, I scrolled to the wrong place. I was like, where are we? We're now within the externcy block, but not within the unnamed namespace. Okay. So we got a std unique putter of the return type. Our deleter is this std tzdb delete time zones. Yep, which will then new no throw this, like those braces. If we couldn't acquire, then return null. Call the acquire function. If it's less than anything less than success, then report when error. That'll do that release thing. That you error, set the version. If that failed, report an ICU error. You enum close. Okay, so now we're going to enumerate through. Yeah, because we're going to get all the time zones. Okay. And if that failed, report an error. Enum count may be expensive, but it's required to pre-allocate arrays. Okay. Enum time zones. It's not our first local variable. That's not an error. That's not a unique putter. Yes. Can this be const? Sure looks like it. In fact, do we do anything with this other than immediately static s size t? No, we don't. Okay. Yeah, I think this should be const. If you failure, you error, return report error, ICU error. Okay. From time zone, static s. Okay. Okay, we've got a raw allocation here. But it's okay, it's being owned by info, and we're going to have std tzdb delete time zones handle this. That's going to go through, and if we have any names, we're going to delete square bracket all of them. And if we have any links, delete square bracket all of them. But these had either better be allocated or null putter. Okay, so let's see what happens. Got the manual memory management. Okay, so we try to allocate a std time zones info struct. Okay, it's not an array. And then okay, oh, and it's the, I'm looking for the code. It's just right after this. Great. We're going to new up this null. You know, in fact, I think, trying to remember the rules, I think you can brace in it an array. You I'm like 99% sure that works. Let's check the standard. That fill-in may not be necessary. Okay. It's been so long since I've done a new square bracket. That is, what kind of expression is this considered unary? Okay, so in the standard, you can new up. Let's see. Yeah, this is where the square brackets come from, and then you can provide an initializer. Yeah. Yeah, and you can initialize an array even with lots of elements, but no element should be fine too. Yeah, this should totally work. Yeah, and we use the direct initialization rules. And if you brace it in an array, you get all nulls. Yeah, I think I'll suggest that here because it's I consider it to be slightly safer to have those empty braces immediately rather than worrying, as I just did, about where are they being assigned at all. And in theory, possibly better to optimize, certainly better, a little better for throughput for compiling the STL. That affects both of these. So I can comment on this here. Okay. Instead of fill in with null putter, you can use empty braces after the array to initialize the elements. It's really value initialize, which is going to do null putter. Initialize the elements to null. For example, new int. I'll just provide an example rather than writing out the thing. A new int 5 empty braces. Yes, that should totally work. And if it doesn't, then I'm very wrong. And then trying to think about the clarity. The comment here is kind of nice. Like, it's not usually the case that like empty braces are super critical. I kind of like the comments. That makes me wonder, like, is the code as is fine? This is like super explicit. Yeah, and these all match. You know what? This is like, yeah, we could save a couple lines, 4 lines, or maybe 2 lines, but honestly, this is clear. Comment. Yeah, we could just keep the comment. Yeah, that's a good point. Yeah, keep the comment, and then it is initting them, because if you don't, then it's default init. Yeah, that's a good suggestion. Keep the comment. What if the comment should be slightly extended to say value in it? Yeah, the empty braces, it's going to go through, yeah, value in it and then 0 in it. Yeah. The comments can be kept and updated to say value in it, which is what it's requesting. Mostly because like default in it is what you get otherwise, and that's just garbage. Okay, thanks. Okay. Yep, there we go. And then now let's iterate through. For name idx 0, less than num time zones, plus name idx. Num time zones is the one that was static cast, size t. Yep. Okay, we got an int32 lmlen that's initially 0. Let's see, we got lm here. Okay, so nitpicky things that come to my brain are, can this be top level constant? Also, do we need to say star here? Usually we don't bother saying star with auto. You know, if it returns a pointer, auto will get that pointer. I would kind of expect to see, oh, this is actually real weird. This is saying it's a pointer to const auto. So this const is actually not top level. Yeah, usually we just rely on the type system saying, oh, you know, if it's a pointer, then we can do pointery things to it. I guess this is emphasizing that it is a pointer and not like an individual character element. I think that's fine. It's not wrong. It's just a little unconventional, but we're doing unconventional things here. I do kind of want that top level const though, because I don't think I see any modification. Oh, it's a substring. Okay, we make a U16 view. Yeah, I think it can be top level const. Whereas we do need to assign to lmlen. Just inline suggest that here. Yeah, and this is a little easier to parse actually because it's like, oh, const auto star const. Okay, this is clearly a pointer with 2 levels of constants. Okay, so if it failed or if we got null pointer out, then report ICU error. We had initialized all these elements to null, so now we can individually assign them to non-null. Allocate wide and arrow. If that thing that we just got failed, then propagate error info. Okay, so failure, it's null footer. Okay. Link len. Oh, so this is all interesting. Here, we're clearly getting a pointer, but now this is just top level const. It's not auto star. So this is inconsistent, which makes me think the first one should just be const auto.
You're getting a unique pointer, not a pointer.
Oh, it's not a raw pointer. Oh, that's interesting. Okay, yeah, I always forget you can test unique putters like that. Yeah, you called out get. Okay. They could still both be const though. Although interestingly, this actually I don't know the rules here. Is this spelling to add constants to a pointer? I think it actually does. I think that's the one thing the syntax will do. It's just I never use the syntax. I don't know how the rules work. This is fine. Okay. Const auto link. If we didn't get it, we could use operator not, but this is fine too. It's consistent, which is good. Okay, so now we're going to do string tests. We had included string view. If you try to make a U16 string view from lm, if they are different, then allocate wide and narrow in the links if we didn't get it. Okay, that all looks good. Nearing the end of the file, and we're just at the end of our time slot, so I'll review this function. This is when we delete. I'd already scrolled down here and looked at this for a bit. Okay. Info could be top level const, but it wouldn't really buy a lot here. It's a long function. It would buy a little. I'll ask for it. I like my parameters to be top level const. That would, we don't need to worry about, oh, you know, what if we accidentally say info equals null putter rather than double equals? Info top level const pointer blah. Yep, that looks good. So if we have an info, if we have an info names, then iterate through, delete square bracket everything. And then since we already had to do a test, we may as well put this inside the test, which is good. Delete square bracket info name set at null. If we have links, iterate through, delete square bracket. Oh, hello, copy pasto. This is names. Yep. This is not links.
Mm-hmm. Good catch.
Thanks. Yeah, the trick is after an hour 30 of code review to find the one copy pasto near the end when you're about ready to say, okay, time to call it a day. Copy paste error. But they are the same length, num time zones. Is that correct? Where do we allocate these? Was that new no throw? Yeah, both are the same lengths. That's good. There's no copy paste over there. Okay. And now get current zone is second to last function. No discard, turn the pointer, stood call, no accept. If the info, which is the thing we're returning, if it's null, then bad alloc. Same suggestion as before. No reason for parens. Also consistent with just runtime error. Okay. If the error is a win error, then failed, call get last error. If it's ICU error, then it's a runtime error interacting with ICU. Got a std unique putter for current zone info, delete current zone. Okay, these match. New no throw with braces. If we couldn't get it, return null. If it requires less than full success, report error when error. You error code error brace brace. Do we usually say success here? I thought I only saw brace brace for like zeros. Yeah, every other one initializes to U0 error. These are just the wrappers. I think U0 error would probably be better, even if that does happen to be zero, or yeah, zero, actual zero. The previous lines used on initial value of blah instead of empty braces. Should we be consistent here? I got a char 16T ID buff. Spending 512 bytes in this function is probably fine. I assume this is the maximum.
I can do the same thing as we reviewed before. And
get the length and then
yeah, I can make it much smaller.
Okay, would we need to allocate, or I guess are we allocating anyways?
We could make one not allocate and the other allocate, but it would make the logic would be complicated looking.
Well, is this a documented upper bound for how big it is, or is this just a is it just like
arbitrary
56
choice.
should be enough? Okay.
This is just I did the other one, but I didn't see this one, so I can do this one as well.
Okay, cool. I mentioned that this is an arbitrary size, and this code can be changed to follow the other pattern of query the size, then allocate. Okay. Okay, const auto ID buff then is get default time zone. So this code will change if it failed or if we got 0. I thought other code asked less than or equal to 0. Maybe it wasn't exactly that.
Yeah, and it wasn't in the API service. I just strengthened it.
Okay, I'd probably recommend strengthen and be consistent here, because if it returns negative, that does seem like a severe betrayal. Yeah, that's the only occurrence here. Testing for less than equal 0 would be more consistent with the previous test, even if the API doesn't say that negative is possible. Okay, report error, that's an ICU error. Info TZ name is allocate wide and narrow with ID buff len. If it's null, propagate error, info, otherwise release. Okay, then delete current zone. If we got info, this one may as well be tuple of cons for consistency, even though it matters a lot less for this small function. then delete square bracket the TZ name and null it out. And if this happens to be null, then there's no harm here. We brace allocate this here, so it will be null if we encounter error later. So that's good. Okay, and again, no mismatch issue because it's all happening within the DLL. Okay, so that's that file. We reviewed all the separately compiled code, which is the stuff I'm generally the most paranoid about. Did not have time to review the test changes and the Chrono stuff, which Mia has reviewed, which is basically the same position I was in with the previous PR. So I'm accumulating a lot of review debt that I'll need to pay off when we do the final merge, final pull request to feature Chrono into main. But I think this is sufficient to proceed with this PR because I know we've got another PR that'll be following this. Yeah, there's the other files. So I will approve with comments. I think once the issues like the copy paste on those others are resolved, if Mia's happy with this, then you can go ahead and merge this into feature Chrono. Okay, so I think that does it for this review. Does anybody have any questions for the things that we covered? Which was it felt like a solid 30 minutes of me reasoning through atomic and weaker than sequential consistency and things like that.
Yeah, I was unclear on that stuff myself as well. So
yeah, a lot of it is just like imitate existing patterns, and the issue is always like, what if you change something that was a critical assumption? But I think I convinced myself that what we're doing looks pretty reasonable. And aside from the one change of the compare exchange going to acquire release for consistency with the individual acquire and release, it all looked good. So what we're doing there is not terribly concerning. It gets real concerning when we start mixing in like multiple threads and multiple states and multiple atomic variables. But here it's really, okay, multiple threads could be in the detecting phase and they could overwrite the pointers with the same non-null values. That's fine. We've carefully avoided data races. So I'm feeling pretty good about that code. That's actually the thing I'm like maybe the least concerned about.
Yeah, I think the atomic code itself had like a backup option if it couldn't succeed, whereas in our scenario is we just fail if something isn't initialized. So maybe the atomic code was more complicated.
Yeah. Here we expect, and the only reason to expect failure is if we can't load the IC DLL. If we can, we pretty much expect everything else to succeed, but having that extra code to verify, okay, we actually can load all the function pointers is definitely a good.
And thankfully, we've been able to test that because the build machines were old. So we know that throws the right exception.
Yeah, even though they were just aborting, we did get failures, so that's good.
Oh, no, I checked later and it was throwing the right exception. I updated the tests and saw that it was flowing through the right error path.
Okay, that's great.
Okay, I will stop the recording and transcription. And I think